Hi General Math students. In this video we're going to discuss flow through a network. So what we're looking at here is what is the maximum flow through a network based on the capacity of edges. For instance, this network shows the flow of some urban streets in cars per minute. Okay, this one here. So from X through to A, for instance, 90 cars per minute can travel along that edge. 30 from X to B. Once we go from, when we're trying to go from A to Y, we can get only 20 cars per minute and 40 cars per minute along this edge. X is the source of this network, the source, and Y is the sink of the network. So like the finish and the start of the network, we're going to call them the source and the sink. So the source is the vertex that has all the edges leading away from it. The sink has all edges leading towards it. So in order to calculate the capacity the flow of this network, we can actually do it by inspection. And as described down here in this paragraph, the maximum flow along this side of the network, I'll do this one in red, through here and here. Now we can go 90 along this edge, but only 20 here. So even though the cars are going to be, lots of cars are going to be going along here, they're going to get held up by the cars that are, well, they're going to be held up by this edge, which has lower capacity. So it's a bit like a chain, the weakest link in a chain. A chain is only as strong as its weakest link. So a route through the network is only as fast as the slowest part of that route. So in this case, we can get 20 along that red route that I've detailed there. If we go down this way on a blue, we've got 30 along here and 40 along here, but the maximum would be 30, because even though these cars, once they get to here, we can get 40 cars per minute along this edge. There's only 30, so along this edge, 30 cars per minute, so they're going to get held up along there. So we add up all those to capacities to get the maximum flow of the network. In this case, is 20 plus 30 to give 50. So it's basically look at all the different routes that are possible and find the slowest part or the smallest number along any of those routes and add those up for each of the ways you can do it. Let's look at this one. You might want to pause the video at this stage and have a go at your own, have a go on your own, and then I'll have a go at it. So here is our sink, and here, sorry, got that the wrong way around. Here is our source, and here is our sink. So one way we might go is through this way, and the lowest number on that is 20, so I'll record that up there, and I'll rub that out. We could also go this way, and the lowest number of those two is 15. And the other way we could go is down through that way, and the lowest of those numbers is 10. So we'll add those up to get 45. So that's the max flow for that network. Okay, next one. Here we've got the source. Here we've got the sink. So going this way, we can get 40 is the lowest of those two numbers. We could go along this way, and the lowest is 10. Or we could go down this way, up this way, and down there. A bit of a zigzag. The lowest of those three numbers is 10, which gives a max flow of 60. Okay. Now, there is a more sophisticated method than doing this by inspection, and that is making cuts. A cut is just basically you draw a line, physically draw a line that cuts through the edges of the network like you see here.
Yeah, and what we do is we add up all the edges that are cut by that, and we see if we find that minimum cut. Now, the best way is just to show you with an example, but just a note here: the cut must separate the source from the sink, right? So this one here does not work, because if you did that, you can get around that way and you're not touching that cut. The cut must separate the source from the sink, so any route you would take goes through the cut. See how I'm going through this cut here and that one there? All right, so we've got to make valid cuts. They've got to go through and separate the source from the sink. Righto. Now this is a little complicated. I'll describe this in an example as we go, but we only add up edges that are cut and are separated, where the cut, where the edge is flowing from the source side to the sink side of the cut. Okay, I got a bit tongue-tied there, so I'll just talk about that again. So we add up the edges, right, that are flowing from the source side to the sink side. Okay, so what that means, for instance, in this cut here, actually I'll switch to red, so see this cut? All right, now see how this edge, right, it starts on the source side and goes to the sink side. Can you see that? So we will add that 30 will count. This edge does the same, starts in the green and goes to the yellow for the sink side. There it is, the 10, and this one does the same. So we'll count all those edges. If we look at this example here, here's our cut, right? Now, this edge is cut and it goes from green to yellow, the source to the sink, so we will count the 40. Now the 10, right, is coming from the sink side to the source side. So that is not included here when we add up all the capacity of the cut. The 20, this other edge that's cut, is coming from the source side to the sink side, so that 20 is counted. Now look, you may still be a little bit confused by that, but hopefully as we do an example and with some experience, you'll start to get an idea of how that works. I mean, one thing I say is that you'll notice that for the ones in this one that do count, see how the cut hits on the top side or the left side of the edge, whereas for this one that doesn't count, it's hitting on the bottom side of the edge or the right-hand side of the edge. It's a little confusing, and maybe that wasn't the best description, but let's look at some valid cuts, and I'm sure that we'll get the idea as we go along and practice these. So let's have a go at these two here. So if you're feeling confident, you might want to pause the video at this stage and try these on your own, and then I'll have a go at them and we'll see what we get. All right, everyone, so I'm going to make some cuts here and let's see what happens. So the idea is that we're going to just make some cuts, and I'll start with this one, and that one gives me 20, 10 and 10, so that cut is 40. All those edges count, they all are separated from the source to the sink. Okay, I'll do this one. 20, 10 and 12 makes 42. Let's try this one here. 8 and 25, they're the only ones, they both count. So that's 33. Okay, so you might have played around with this a bit more, but I'm thinking that 33 is our minimum cut. All right? Now the minimum cut, as we say up here, is equal to our maximum flow. So that means max flow is 33. So whatever the minimum cut is, the smallest cut you make, that is your maximum flow. You might want to stop now and practice this second one, armed with that knowledge. Then I'll have a go at it. Okay, so let's try again with this one. So I'm going to make a cut here. What have we got there? 20 and 30 make 50, 10, 60. Let's put a cut through this one. Let's go here. Like that. So we've got 20 and 8 makes 28, and 15 makes 43, and 8 makes 51, and 10 makes 61, a little bit bigger than the previous cut. So far the minimum cut is 60. Let's go right up the end here before we go in between. And 30, 10, and 20 is also 60. Let's try this one down this way. What do we get for that? 30, 15, and 15 make 60. And oh, that's way bigger. That's 80 when we add that 20 onto it. However, oops, I've made a mistake. I'll just let you see this. This is a good opportunity. And as usual, I've made the mistake deliberately. That is not 80. Can you think of why that is not correct? I'll give you a few moments to think about it. And you might want to pause the video to think. Okay, so the answer is that this cut should not count because that edge, see how we're coming this way and we're coming from the wrong side of that edge. So we can see that we're coming from the right hand side of that edge, or that does not. So there's an example of not separating not going from the source side to the sink side with that cut. So if we were to look at this, all right, let me demonstrate. I'll put that cut back in there. Okay, so this is the one we're talking about. And if we make a bit of a color thing here, so this is the sink side of this. See how the edge is coming from the sink side to the source side. That doesn't count. Whereas this edge is coming from the source side to the sink side. That does count in the cut. So hopefully you're starting to see the reasoning behind that. So in fact, that's not 80. We wouldn't count the 15 there, so it would in fact be 65. But despite that, I can't find a smaller cut than the two 60s there. They're equally low. Just have another quick look. 45. No, I just can't see one. Correct me if I'm wrong, but I think that's the lowest cut there is. So the minimum cut is 60 on this one, hence max flow is also 60. Righto, now doing the cuts and finding the minimum max flow minimum cut is not all that difficult for these, but understanding which edges should count in the cut can be a little confusing, but we'll work on that. So go ahead and look at the questions in the description for the video and try some of these types of questions.